All right. The other big, specially named continuous distribution we talk about in chapter 6 is the normal distribution. Probably one of the most widely used in science, business, and any kind of research. It's this symmetric mouse shape, split down the middle 50-50. Again, the numbers on the number line are the values that x takes on, where the height of the curve indicates the probability that those values occur. So values close to the mean occur with high probability, and then values further out from the mean on either side occur with low probability. Continuous distribution, so we have the same properties that the uniform distribution has. Your textbook talks about calculating z-scores and looking up the probabilities for z-scores from a table. You're welcome to do that, but in this video I'm going to show how to do that with Excel quickly. I have the formulas typed out here. You can read through those if you want, or this video should hopefully just explain what's going on here. I'd invite you to follow along with the handout posted on Canvas. We're going to go through example 1, these things. My random variable x is just a general example, no story behind it. X follows a normal distribution with a mean equal to 0 and a standard deviation equal to 1. Here I just copied everything over to Excel, the problem statements, since we'll be using Excel to solve these. We're going to start with A. Before we calculate anything, we always just want to draw out the picture so we know what area or probabilities we're calculating. We know that x follows a normal distribution. Normal distribution looks something like that, mountain-shaped. Centered at the mean, our mean is 0. And we want the probability that x is less than 2.3, or the area under the curve that is to the left of 2.3. I need to calculate that area. We can't do this base times height thing that we did for the uniform distribution because this is a curve, so that doesn't work. We could use calculus and use integration techniques to get the area under a curve, but that would get really difficult. So Excel has this easy to use function called normDist. My x value is the 2.3. The mean of my distribution is 0. The standard deviation is 1. This cumulative option, for a continuous distribution, I'm always going to select true, that I want the cumulative probability distribution. And there we go. Going back to this last argument, the true or false for the cumulative distribution, when I put true, it returns this, x less than a value. If I put false, it returns exactly equal to a value. For a continuous distribution, the probability that x is exactly equal to any number is always going to be 0. So we're always going to put true. We need to calculate a range of values, never one specific value. Again, we're going to start out by drawing this out, calculating the probability that x is greater than 4. My normal distribution curve, same distribution, so it's going to be centered at the mean, 0. And we want the probability that x is greater than 1.4, or what's the area under the curve to the right of 1.4. Here's how we have to get a little creative, because our Excel function only returns values to the left of a specific value, only going to the left. I need a probability to the right, though. How I do this, I know the entire area under the curve is equal to 1. By definition, this is a probability distribution, so the whole area under the curve must be 1. And then I'm going to take out what I don't want. I don't want this yellow highlighted area. To compute that yellow highlighted area is the probability that x is, that's the area to the left of 1.4. This formula here will give me the shaded region that I want. To do that in Excel, for part B, equals 1 minus this norm.dist. X value is 1.4, mean 0, standard deviation 1, and we always want a cumulative. Part C, what's the probability that x falls between 1 and 2.2? Start off with the picture. So I want the area under the curve between 1 and 2.2. This shaded region is what I want. This one we have to get really creative. If I start off with calculating the probability that x is less than 2.2, this is all I can do in Excel. Left-tailed probabilities, we call it. This piece right here will calculate for me everything to the left. That's too much, though. I need to stop it at 1. So what I need to take out is everything to the left of 1. To remove that, I'm going to subtract out all the probability, or all the area to the left of 1. Probability x is less than. This formula here will give me this shaded pink region here, what I need to calculate for part C. In Excel, we can do it all in one, equals norm dist, my x value, 2.2, always cumulative, for a continuous distribution, minus the second piece. Part D is a little bit different. Here we're trying to calculate probabilities based on given x values. Part D now is reversed. We're given a probability and we want to know what the x value is associated with that probability. So we're told the probability, or the area, to the left of this k value is 0.26. What's this k value? We have a new formula to find that. This is kind of the opposite of what we've been doing here. It's the inverse. So our formula actually is called norm inverse. The probability that I'm entering is always a left-tailed probability. This is a left-tailed probability, so I can just go ahead and enter 0.26. The mean is 0. Standard deviation is 1. Enter. That makes sense. We get a negative number because it's to the left of 0. So this k value is 0.64335 on the number line. Last one. It's similar to D. We're doing kind of the inverse of what we've been doing in parts A, B, and C. We're given a probability. We're asked to find what the number on my number line is associated with that probability. So we know the probability, or the area to the right of this number, is 0.44. What is the k value there? Now, to use the norm inverse function, this probability has to be a left-tailed probability. Can't enter 0.44. That's a right-tailed probability. We need to enter a left-tailed probability. We can find that just by doing a little bit of math. We know the whole area under the curve is 1. So 1 minus 0.44. Therefore, this side has to be 0.56 is my left-tail probability. Left-tail probability, 0.5601.